All right, let us go through these.
The first one is not something I'd put on a test because it really is kind of a trick question. Who said yes on the first one? It's actually no. And I had you all raise it. I mean, we all thought it was yes. In fact, just on the surface value, it looks like it has to be yes. Once again, this will not be on the test, but there is a way to draw this like a diagonal where B isn't the midpoint. So let me draw that real quick. So I'm thinking something like this, where we have AB here.
Yeah.
Yep. And then we have BC here, where I make both of these congruent. They are congruent, but B is not a midpoint. So it's a little bit of tomfoolery, but the answer is no. Once again, I wouldn't put that on a test, because my goal on the test is that you know that midpoint means smack dab in between. All right. Yes?
Would it still be a line segment even though it's like
Would from A to C be a line segment? No.
but it says midpoint of segment AC.
Would it be the midpoint? So this is not a segment, but what they're saying is if I was to draw a segment, is B the midpoint of it? If it existed, or if I drew it, would it be the midpoint? B would not be that midpoint if I drew it. I see the semantics of that, yeah. All right, number 2, on ray AB, how many points are there whose distance is exactly 3 centimeters?
1.
There's exactly 1. Let me draw that picture. It's always a good idea. And I'm going to say this over and over and over. In geometry class, if you're stuck on a problem, draw the picture. Don't just sit there and look at a blank thing, because it specifically says AB. So even if I don't know how to do this problem, I'm on a test, I don't know how to answer this question. At the very least, if I put ray AB down here, and I don't do any other work besides that, you can get some points because you understand that I'm talking about a ray. You're showing some understanding of that problem. If it's 100% blank, I can't give you any points. So if you're ever stuck, draw a picture. All right, now I have that picture. And it says, from point A, how many points are there that are exactly 3 centimeters away? So I'm going to pretend my fingers are a ruler, that this is exactly 3 centimeters. Well, actually, that'd be like that. But we're going to pretend this is 3 centimeters. All right, this is 3 centimeters. When I put my thumb on A, and I go to here, there's only one place on the line that's exactly that measurement away. If I come over here, anywhere else, there's no other place where that measure is 3 centimeters. That's why when you looked at that answer key, I had kind of a circle. Well, first of all, I had like 3 centimeters. That's my measurement. I had kind of a circle on it. That circle had a radius of 3 centimeters. I'm just showing you that no matter where else I measure, there's only this one place that has that point. So it's just 1 point. Anyone confused by that at all? Kind of have to know this. Yes?
So what's the distance from A to B?
We don't care.
Okay.
Nope. B could be right here. This point still exists as 3 centimeters because it's a ray. It goes on forever. It has B. This is just basically showing you it's a ray going in this direction. Doesn't matter where B is. There's still just one point that's 3 centimeters. B could actually be this point. I just say that there's at least one, and there's exactly one point that exists. That's 3 centimeters. Does that help answer your question a bit? Okay. All right, 3. Now we have a line. I'm going to draw it first, and then I'll ask the question. I'm going to put A in a very specific place to help me. How many points are exactly 3 centimeters away from A on this line, Sophia? There's exactly 2. Once again, this is my measurement of 3 centimeters. If I stick the ruler on A, right here is a point that's 3 centimeters away. And if I flip on the other side, this is 3 centimeters away. So we have either 3 centimeters this way or 3 centimeters that way, which would be our 2 points. Once again, on my answer key, I put a little circle saying, there's no other place that's 3 centimeters away. This is every place that's 3 centimeters away from A, it hits the line twice, so there is exactly 2 points. Once again, it's important that you know these 2 things. Those are big things. All right, questions on the homework. What questions do we have on the homework? Let me get the homework out first. Questions on the homework? No one's going to get the ball rolling. Nerfing. Nothing over here. Nothing over here. Nothing here. There we go. I knew I just had to wait long enough.
47.
For 47. Oh, okay. Yeah, that's like, it's kind of like a version of this one, right? It says on ray AB, how many points are there whose distance away from B is 3 centimeters? This is where Songhao was asking about the distance. This is the only time the distance between A and B matter. Because if I draw AB, if I draw AB, right? And let's say this bar is 3 centimeters. How many spots are there that's exactly 3 centimeters away from B? If this is 3 centimeters, do you see this one? And then do you see this one? So in that case, if it was this long, it would hit twice. What if 3 centimeters was this long? Would it hit out here? Remember these rays going on forever? Would it hit out here? If I came around, would it hit over here? No, then it's 1. That's why on the answer key, we basically had to see how was 3 centimeters measured on there. So I said if the distance between A and B was greater than 3 centimeters, so say this distance is 6 centimeters, then it could hit twice. If A and B are too close together, it can only hit on this side and it would just go around on the other side. Is that? Yeah, this is probably the most challenging out of it because it's got 2 different situations. That's when we care about that distance from A to B. That's the only time we care about that distance. Other questions? Yeah, Dave. Yeah.
You have to, like on the test or quiz, we have to put the second explanation that if AB is smaller than B.
It won't be on the test, but yes, you would have to. You'd have to put both of them. Once again, it won't be on the test. If I was going to put ones on the test, I'd put like the ones before it where it doesn't have 2 situations. All right? Because this takes a lot more thought, and it's 2 different things, and I don't want to push you in that direction. Yeah. Did I answer your question? I'm sorry. We're good, right, Davion?
Yeah.
Good. All right. Yeah.
For 43, I was just kind of confused.
Okay. 43 is the absolute value is less than or equal to 4. So we have absolute value of x is less than or equal to 4. So what I like to do when I get confused on these, especially with absolute value, I start plugging in values to see if they work or don't work. So what I'd be looking at is, okay, we have something to do with 4. And I'm going to ask myself, does negative 4 work? Is the absolute value of negative 4 less than or equal to 4? Yeah, it is. What about negative 5? Negative 5 doesn't work for that one. So it'd be like negative 4 works. Negative 3 would work. Negative 2 would work. All the way up to a positive 4, 5 wouldn't work. So I'm looking at the number line between -4 and 4, and that looks like GT, so it has to be a segment GT.
Okay, yeah.
Is that enough, or do you need to see the pictures of it?
I got 43 and 44 wrong, so I understand. I get it.
Oh, okay.
Yeah.
44, any number actually works for that.
Yeah,
Because absolute value is always positive or equal to 0. So that's why I had the whole line. Other questions? We got the ball rolling. Once, twice, 3 times. All right, then let's start today's lesson. Today's lesson is on angles, or more traditionally called angles. All right, an angle. And what's right next to it is just the symbol for angle. When we're talking about lines, we draw a line above it. When we're talking about segments, we draw a segment above it. When we're talking about rays, we draw a ray above it. With angles, we're going to put a little angle, but right before it. So the symbol for angle is just a little angle, a little acute angle. Let's go ahead and draw an angle and talk about the important parts of it. Boom, boom. Boom, boom. I'm actually going to slide that over just a little bit to the right. Maybe I will. Maybe I'll just draw more stuff on it. I want a little bit more room. There we go. I'm going to label some things on it. I'm going to label something up on the left ray. I'm going to name something right where they intersect. And I'm going to call that C. That is an angle. And what comprises an angle? You see that B right there? That is called our vertex. That is called our vertex. So we have a vertex right here, and you see how these are 2 rays? We have ray BA, and we have ray BC. Those rays are called sides. So this is a side, and this is a side. So we're going to name this angle, and then we'll name its parts. All right? When naming this angle, there's multiple ways to do it. Least effective way first. You can name an angle by just naming its vertex. You can name an angle by just naming the vertex. That would look something like angle B. However, that is not the most effective way to name an angle because here it's awesome. There's one angle B. Yeah.
Well, what if there was like another one on the other side or we had the same vertex?
You mean like down here? If I said your entire grade is dependent on you drawing angle E, you have a 1 in 3 chance of passing this class if I'd say that. Because there's actually 3 angle E's. That's why we have 3 different angles right here. So the only time you're going to name it with just one letter is if it's just an angle hanging out by itself. All right, if there's anything else touching it, we'll generally go to this next method, which is using all 3 named things here. So I have an A, a B, and a C, and we can either do it in that order, A, B, C, or we can label it C, B, A. Your vertex must be in the center. Your vertex must be in the center. So this might be one of those times I will say something and sometimes I won't write it down. You need to take it on your own accord to write some things down. So if I was taking notes and a teacher said the vertex has to be in the center, I'd write that whether they wrote it on the board or not. So your vertex has to be this center. The last way we label it is if we look down here, you can actually put numbers right in that little crease area. So I'm going to go ahead and do that. I'm going to put 1 right there. If there's a 1 there, you can go ahead and call it an angle 1. All right, up the side, if I asked what's the vertex of this, all you do is you'd write B. If I asked for the sides of this angle, you would write ray BA and ray BC. It is always a ray. Even if in the drawing it doesn't appear to be a ray, like let's say I don't have these on there. Boop, 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 boop. Boop, 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 boop. We're still going to name them as rays. I'll put them back. Yes?
What about if it's like a line and they just like, do they still count?
It's still going to be a ray. Your side will always be a ray. But remember, so I get what you're saying. So you're saying, let's say this cuts, nope, that ain't going to help. All right, let's say you're saying that.
Yeah.
If I'm talking about angle 1, I'm forgetting about these.
Right.
It's almost like if I was talking about a segment, you forget about all the other stuff except for that one segment. Even if they're all lines, your side is going to be those rays, BA and BC.
All right.
Yes.
So how do you know which way the arrow should be?
The arrow's always going to be from your vertex to up. Right? When we're labeling rays, see how this is my point? See how this B is right below that point? And this A is that direction of the arrow. This A has to be that direction of the arrow. It has to match the direction of the ray. Did I answer that? I feel like I just kind of went around in a circle. You're good? All right. All right, example 1. We're supposed to name 3 different angles below. Even though you can call several angles different names, they're still the same angle. All right. Can someone name one of the angles that they see there? Yeah.
Acute.
You see what?
Acute angle.
Oh, you see an acute angle. Yeah, I haven't got to that yet.
Oh.
I mean, can you name an angle you see?
R.
There you go. R-E-T. Sorry about that. Angle R-E-T. That's one of them. Sangha? Angle 2. Or you could name it with the letters. So you could say something like R-E-S. Or you could go S-E-R. What's your last one? Angle S-E-T set. Or you could have labeled it angle 3 because there is a number there. Yes?
What about on the outside? Does that count? Like R-E-T?
So in geometry, it's not going to go in both directions.
Oh,
RET is the exact same angle as TER. It will always be this inside angle. We're never going to talk about this outside.
okay.
Well, we're not going to talk about the outside in our class. All right, we're going to say they're all the same. Because I know there's lots of math software that depends on which way you label it is which direction you're going. And this, we're just focusing on the angles. Because we're building up the triangles and stuff. And triangles, you're not going to do the outside.
Right, yeah.
That's our whole goal. Yes?
For angle RET, could you say angle 5?
You cannot say angle 5.
Okay.
You can't add those up.
Okay.
So RET is the only thing. You can name it TER, but you cannot name it with a number. And you can't say like 2 plus 3. You have to just call it with those letters. The numbers are only shortcuts if the whole angle is labeled by that number. Is that good? All right. So those are naming and parts of an angle. In geometry, angles are measured in units called degrees. We will not be using protractors in this class. This is just a quick example. All of what we're doing are like hypothetical, like I say, draw a 45-degree angle, and you approximate it. We're not going to do exact where you're measuring stuff. In fact, the most important part of this is reconnecting. All right, my important part about this is when we're going one direction, I'm looking at this as being a 0-degree angle. If it opens up to that its next one, I'm looking at a 45-degree angle. Our top one's 90 degrees. Way over to the left is 180. And smack dab in the middle is 135. Honestly, in this class, you just have to get close to things. So if I ask for a 45-degree angle, I just want you to know somewhere around here that is an acute angle. If I say 90, it's about here. If I say like 120, you put it somewhere over here. If I say a 5-degree, you know, it opens pretty small. So some examples of what I'm talking about is if on the test I say draw like a 90-degree angle. all I'm expecting you to do is just draw something like that. And then with 90-degree angles, they do have a symbol that stands for 90 degrees. All right, so that's an important one. Let's say I asked you to draw a 20-degree angle. I'm not asking for perfection. I'm just asking for just something that opens a little ways. That, 20 degrees is a small angle. It's less than 90, way less than 90, so it's going to be a bit smaller. And then if I said something like 110, once again, nothing perfect. Just make sure it looks like it's past 90. Easy enough. No measurements. I don't need you to bring out protractor, so it's perfectly 110 degrees. It's just going to be a rough sketch of stuff. All right. We've already heard talk of acute. What does acute mean since you brought it up? It's going to be less than 90 degrees. I'm just going to put from 0 to 90 degrees. It does not include 90. Does not include 90. Example of acute angle would look something like this. I was like, because they're the small angles, they're acute angles. They're acute angle. It's a cute angle. Look at that little guy. Obtuse. Bleh. He's obtuse. He's going to look like that. So he's going to be bigger than 90 degrees. So we're talking 90 degrees to 180. Not including 90 and not including 180. Just like acute wouldn't include 0 because that'd be just a line. Right angle, that's exactly 90. And don't forget your symbol. Whenever I draw a 90-degree angle, you put that box in that corner. Straight angle seems to be the one that trips people up, especially when you're looking for something. Yeah, sorry.
No, I was just...
Oh, you're going to answer? Awesome. What's a straight angle? 180 degrees. It's just a straight line. But it's weird. It's weird because you can name a straight line an angle. So it looks something like that. And it would have a vertex and points, just like everything else. It's just open to 180 and it's just a line. Quick review. Are these opposite rays put together? Why not?
They don't.
They have to be on the same line. Yep. These are not opposite rays. To be an opposite ray, it has to be on the same line. Just trying to get the opposite rays down. Yeah.
Straight can be opposite rays.
A straight can be opposite rays. Yes.
So would a 0-degree angle just be a ray?
It would just be a ray. And we don't talk about 0-degree angles. We talk about 180, but we'll never talk about 0-degree angles. Because there's no point, because it didn't go anywhere. It's just like, how far did I get to my car? Well, you didn't even start walking, kind of. Nothing happened, so it's not interesting. Adjacent angles. Adjacent angles have to have a common side and so both things have to happen and the exact same vertex. Once again, common side and exact same vertex. So an example of adjacent angle. Let's label this real quick. Let's call this A, B, C, and we'll call this D. Note the same side. They're sharing that side. So if I look at ABD and DBC, they have this shared side, and they both have the same vertex B. So since they have the same side, same vertex, you can then say that angle ABD is adjacent to angle DBC. Yes?
What do you mean by same side?
So CBD is in both of those. Let me highlight both of them actually. So we have not red. Do you see this angle? All right, the other angle I'm talking about is, let's do it in yellow.
They share the side.
Yep, they share that side. They both share BD. They're kind of like right against each other. They're sharing a wall. Let's do two quick examples of not adjacent that I've seen in the past that people think is adjacent. I'm going to label these real quick. Angle 1 and angle 2 are not adjacent. Angle 1 and angle 2 are not adjacent. They have the same vertex, but they're not sharing a side. They are not sharing a side. So 1 and 2 are not adjacent. I don't want these in your notes because we're saying things that aren't, so I don't want this in your notes. I'm just hypothetically saying. Would 1 and 3 be adjacent?
Yeah.
Would 3 and 2 be adjacent? So the only two that aren't adjacent are 1 and 2. I'm going to get rid of that 3 because I really want to point out that these two aren't adjacent. Another example of not adjacent, as some people think is adjacent, is... that didn't show up. No. These now share a side, but they do not share a vertex. So 1 and 2 are not adjacent. Think of that when you're doing these, okay? Have to look just like this. There's no way to hide it. There's no way to sneakily have adjacent angles. It basically looks like 3 angles all in one. All right, question on adjacent angles. Worry about both. People forget all the time both those things. All right, congruent angles. Well, congruent segments meant the same size. Congruent angles mean the exact same thing. So congruent angles are angles that have the same measure. What exactly did I put? That's what we're talking about. All right, I got my notes up here. Yeah, we'll just put the same measure. So this is 42, this is 42. They're both congruent. This is just a little note. Congruent angles are also called equivalent. So if you see the word equivalent, it's the same thing as congruent. It's just a little note to yourself that when I say it in the notes or something like that, I mean the exact same thing. Congruent and equivalent mean the same thing. All right, we're going to learn 2 bits of new notation here. We agree 42 is equal to 42?
Yeah.
So we agree that both these are congruent. When you know something's congruent, just like with lines where you put that little tick mark on to show that they're congruent, we have a symbol here, and that's a little arc. If you see an arc here, and an arc on another angle, it means they're automatically congruent. All right, those 2 things are congruent. And just like tick marks, if you see 2 arcs and 2 arcs, that means they're congruent as well. You're looking for the number of arcs to match them up to see which are congruent. So that is our symbol for congruent. So that means congruent. congruent symbol. All right, how we'd write this is I would say something like angle G, since there is only one angle G, I can just call it angle G, is congruent. We use that congruent symbol, which is that equal sign with a squiggle above it, is congruent to angle S. There's another way to put this. When we're talking about segments, if I didn't have a line above it, I specifically said that's the measure of that segment, right? No line above means that's the distance. What we're going to do for angles is we can't just get rid of that angle, because as soon as I say G, we're talking about the point. So rather than writing something without a line, this is the other way we can write this. We can go M angle G. As soon as you see that M, I'm specifically saying 42 degrees. The measure of G is 42 degrees. So M stands for our measure. So the measure of G equals the measure of angle S. So just like distance, measure just is that number that you can put to it. So that is our measure. Bisector of an angle. Bisector of a line, cut it smack dab in the middle, right? Same thing with an angle bisector. The bisector of an angle is and remember our sides are rays? Angle bisector is also going to be a ray. It's going to be something that just bloop, shoots right through. So it's going to be the ray that divides the angle into two congruent adjacent. Oh, what does it mean to be adjacent again? What does it mean to be adjacent again? I already forgot. Sophia? Same side and vertex. So this isn't that yet. So we have to draw a ray. Does that look like we have two adjacent angles? Yeah, right? And what's going to happen is that is going to create two congruent angles. So let's just say that the measure of angle ABC equals 60 degrees. What's the measure of angle ABD? What's the measure of angle ABD? Yeah, it's going to be 30 degrees. It cuts it right in half, right? So if that's 30 degrees, then the other one is going to be, do you want to answer that? I saw your hand lingering. Also 30. We doing okay? Feeling okay? All right, how much time do we have left? I can cut some stuff out. 4:05. All right, I cut a little bit out. I'm not going to spend, oh, sorry. Yeah.
Sorry. When you draw the arcs,
Mhm.
can you, if they're next to each other, can you just do one big one?
Yeah, so traditionally I would just do, so her question is, so see how I kind of staggered them? I do that when we're first learning how to draw them, and I'm drawing two individual ones. But later on, it's going to look more like, whoop. I can't really get a good eraser in there, but I would probably do something like that. I'd probably just show that there's two like that, drawing just one quick. But just because we're just learning, I do want to show that it really is two different marks. Does that answer your question, I think? All right, this we're not going to dwell on. All I'm talking about is, see how these two are congruent? That's congruent symbol. Since these are congruent, that means that this ray bisects ABE. All right, two congruent angles that are adjacent are going to create that bisector. We also have a 90-degree symbol in there, which means the other side must be 90 degrees, because what's the measure of a straight line? 180. So if this is 90, this must be 90 as well. We also know that this is congruent to that, so that's a midpoint. So even though I just put 1, 2, 3, 4, 5, I could probably list 8 different facts that I know just because of those. All right, just be aware of how much information is on there. So if I say something about this angle, you now know something about this angle. We already know this is 90, so that means you know everything about this angle. So a little piece of information filled in here could probably get you a ton of information everywhere else. All right, we're going to do a couple of these. Probably not going to do all of them. They're more or less just if we have extra time, we just go through them. All right, it says name the vertex and sides of the given angle. Let's just do 4. Let's just do 4. Can someone give me the vertex? Just the vertex of 4. So I'm just looking for the vertex. What do you got? C? So C is that point that's at the top of it. So we're talking about this angle here, which is 4. C is the vertex. Can someone give me the sides? It's probably the harder of the two because we just covered that. Simon? Are they lines? What are they? Sides? Well, I'll put those two. You said CB and CD. I want to add something to that. What should I add to that? Because they're not lines. You kind of, yeah. They're rays. So which direction should my arrows go? To the right or to the left? To the right. Right, the rays. Your sides are always going to be rays, okay? Your sides will always be rays. And you'll know which direction to go because your vertex, it should go away from the vertex. We're going to skip down to these right now. Actually, let's do this one. Name all the angles adjacent to angle 6. Can someone name an angle adjacent to 6? Yeah. Angle 7. Who wants to name the other one? Sorry, angle 5. Perfect. So angle 6 is this angle here. Adjacent has to have the same vertex, so we're talking about D. That means it can be angle 7 and angle 5. I do want to do these because it can help you with your assignment. So we have measure of angle 7 plus measure of angle 6. Let me highlight those. So we have measure of angle 7 and we have measure of angle 6. Just like with the segment addition postulate, where one segment plus another segment equals a bigger segment, an angle put together with an adjacent angle makes a bigger angle. All right, so the measure of 7, say it's 42 degrees, plus this, 30 degrees, you just add those two things together and you get the measure of the bigger angle. So the measure of angle 7 plus the measure of angle 6 equals the measure of BDE, the bigger one that we had there. Oh, I still have the wrong tool. All right, next one is measure of angle 6 plus measure of angle 5. What does that equal? What does that equal? Those two put together, what does that equal? We got 2 people, 3 kind of. What'd you come up with?
Angle CDA.
Angle, sorry, I have the wrong tool. CDA. Let's see. So we had angle 6.
This is CDA.
Oh, I said it too, but I wrote E. I said A, didn't I? I think I said it right. And then angle 5, that's CDA, is the bigger of the two. Yep. 15's different because I did not put the measure. Songha, you think you got the answer?
Wait, let me think again.
Okay. I didn't ask for a measure or something. Yeah. Close. We're getting there. I'm looking for a number. Yeah. What was that? 180 degrees. If we look at measure of angle 2 plus measure of angle 3, so if you can give an exact number, that's what I want. So when I'm looking at 3, angle 3, and angle 2, when I put those two things together, their total is going to equal 180 degrees. We know that for a fact because it makes a straight line. So it's 180 degrees. Yes?
What if there's no box thingy on number 2 angle?
Doesn't matter.
Doesn't matter.
If when you put two angles together, so let's say I have something that looks like this, and I put that together with an angle that looks like this. So if I'd say 1 plus angle 2, I would say that equals 180 degrees because it creates a straight line.
Okay.
I don't know what the measures are for the individual angles. This one we knew 1 was 90. These I don't know the measure of 1 and 2. I just know when you add them together they equal 180 degrees. Does that make sense?
179.
What was that?
It can be 179.
No, it's 108. If it looks like a straight line, it is a straight line. Yep. If it looks like a straight line, it is a straight line. I'm not going to trick you guys. All right, everybody. Homework is page 21 through 22, 1 through 22, and 29 through 34, which are already listed on you. Remember, those are just out of the book. If you're in the book, you're on page 21 through 24. If you're just looking through the notes, just work through those. Oh, hang on.
Yeah.
Do you see these 3 little dash marks? That is supposed to be just like 2. So you should have a problem number 1 here. It got erased. It is finding the vertex and sides of angle 5. Vertex and sides, and then get out of here. It got erased when I was printing, I accidentally hit something. And so there should be a problem number 1, and it's vertex and sides of number 5. Have a wonderful, wonderful long weekend. Whew. I apologize for giving you homework, I really do. It's just the nature of when the test is and then I'm missing days. So it is my fault. But you guys will be okay.